Yeah. So, so today we are going to talk about object-oriented concepts, right? We also said that Java is an object-oriented programming language. So basically, you know, what is object-oriented programming, and we will just try to get into these concepts a bit more. Okay. So
వేరే వాళ్ళని అడగాలి ఈయన కాదు వేరే వాళ్ళని అడగాలి మెసేజ్ పెట్టాలి
guys, whoever is not talking, can you please go on mute? Okay. So now coming to object-oriented concepts, right? We in our last class we said that Java is an object-oriented programming language. So basically, what is object-oriented programming, right? In general, there are multiple programming paradigms that are present in software world. Like you have a procedure-oriented programming, functional programming, object-oriented, many programming paradigms. So the goal of each paradigm is to promote and enforce certain principles in software programming, like reusability, maintainability, extensibility. These are like few features, security. To whatever programs we should write, we should be able to write with less code by trying to reuse portions of our code, right? So every programming paradigm that we talked about, procedural oriented programming or functional oriented programming or object oriented programming, they enforce certain rules within your programming languages to make them more robust and very scalable and reusable programming languages, right? So and Java basically follows the object oriented programming principles, right? Not just Java, any programming language to be called itself as object-oriented programming, it has to follow certain programming principles. And if you're looking at the slide, you would see something called class, object, encapsulation, inheritance, abstraction, polymorphism. These are some of the key object-oriented principles, object-oriented programming concepts that any programming language should follow to call itself as an object-oriented programming language. And Java is definitely one of the most famous object-oriented programming language out there. So let's talk about what are the OOPS concepts and how basically Java follows or implements them, right? And object-oriented is basically so integral to Java. So we'll just try to understand what are these object-oriented principles, and which will basically a theoretical discussion of these concepts, that whatever we are going to do right now, right? And yeah, that's all. Now coming to the object-oriented programming principles, right? So normally when you basically design a computer program, any computer program, it basically contains certain two aspects, right? One is basically some data. It can be any data, right? Some data, and then you might be writing some code around that data, right? So in a nutshell, we can say all computer programs primarily focus on two elements, code and data, right? And a program is, we build or we conceptually organize our program around the code and around the data that we are trying to handle, right? And like when I said there are different programming paradigms, right? Object-oriented programming specifically talks about how we can wrap our data into objects, and we define some set of interfaces, and how we can actually how our data, right, our objects itself can control the access to the code, is what object-oriented programming specifically talks about, right? I'll repeat this again. So object-oriented programming talks about organizing a program around its data using objects, right? And it has a well-defined interfaces to the data, like classes, and it basically controls the access to the code using those objects, right? That's what object oriented programming is about. So we'll see, we'll just get into, I know there is a lot of jargon coming right now, but we will try to understand and see what exactly are these terms, right? And prior to object oriented programming, we have the process oriented programming, right? And uh, as the applications grew more, right, there was a lot of complexity that was being coming in process oriented programming. To overcome that, we have object oriented programming approach, which will basically address these complexities that are arising out of a process oriented programming model, right? And if you want me to give an example of process oriented programming language, C language, right? C language, it's basically it's not object oriented. Okay, C language follows the procedure oriented programming approach. So it follows a different principles there. What are principles we are talking here, like class, object, encapsulation, which you are seeing on the slide? They are basically object oriented programming concepts. Okay, so let's just try to write a small Java program, right? And then we will get back to this slide. Okay. So I am going to this IDE, okay, Spring Tool Suite, which I have installed in my machine. So I am going to write a small Java program, and I'll create something called, okay, first I'll show you. I know many of you might be new to using this IDE as well. So let me just show you. Yeah. Anyone has any questions? Okay. So firstly, when you open the IDE, right, go to this new symbol, and it will tell you the type of project you want to create here. Okay, I want to create a Java project. So I went here, Java project, and I select next. And I can give it a name as Java course, right? It's already there, Java course. So Java course 1, finish it off. That's it. Just the name of the project you want to create. Okay. So when you create this Java course, let's try to see in the backend, right, what it is trying to create. I'll go to the source refactor, showing System Explorer. So if you see in your Spring Tool Suite workspace, a folder is created with Java course 1. If you see here underlying, you have an SRC folder, source folder. This is called source folder. Okay, and this is where we will write our Java programs. Okay, so basically when you write Java programs, the first step we need to do is to create package structure. Package structure is like logically grouping your Java programs together, right? Suppose you have 30 Java classes in your application. So 10 classes have one set of functionality and other 20 classes have different functionality, right? We need to create 2 separate folders and put all these 10 Java programs into that folder. Like we need to do some sort of segregation so that it will be easier for us to understand and maintain, right? So we can create some package name here. So I'll come on top of SRC, which is basically a folder under the Java course 1 folder, right? So I'll go to SRC, I'll say new, I'll create package. I can probably give it a name like com.java.trend, right? Something like this. Training, right? And that's it. So I have a package com.java.training. So what is this package name is nothing but it is actually going to create a folder with name com under src, and under com it will create Java folder, and under Java it will create training folder. So let's just see that, right? If you see here, the moment I create a package, you have a com folder. I click on it, you have a Java folder, and under Java folder you have something called training folder, right? So here I'll try to create all my Java classes, right? So I'll go here, I'll say I need to create a Java class, and then I'll say hello. It is just my first program. Okay. So whenever I create this, all Java programs that you write, they are saved as hello.java files. Okay. And whatever name of the file, right? Here the name of the file is hello, _H_E_L_L. H is capital. And the same, if you look at inside it has two declarations. One is package com.java.training. So which is basically from source, in which particular folder path this class is there is what package talks about. Okay, so package com.java.training is simply says that in source folder you have com folder, under com folder you have Java folder, and under Java folder you have training folder. That's where you have this particular hello.java file, and whatever the name of the file, right, hello.java, the same name should be the name of the class also. Okay, and here you have something called public class and then some curly braces, right? So this is how a very basic class looks like, right? And now inside that we can write some code, right? Like say for example, okay. This is the advantage of IDE. Okay, I need to create a main method, so I type some letters and I click on here and I click on this. Automatic, the code will fill automatically. Okay, so you can make use of IDE. IDEs help you to program fast. Okay, now if you see here, I need to create one entry point for the execution of my Java program. So for that, Java has something called main method. Okay, so yeah. Yeah, go on. Who is this and what is the question? Hello? Hello? Okay, I think, yeah, fine. So whatever Java program you take, right, it has one entry point. Entry point in the sense from where your Java program should start its execution, right? So typically all Java programs, they start at main method, and that main method syntax is like this. Method is nothing but a block of statements, a group of statements together, merged together into a method, or it is also called as a function. It is nothing but it will just contain a group of statements in our code. Okay, so in my class hello, I am creating a main method which is basically an entry point for my entire Java application. So I'll come here, I'll write some syntax like this. So again, I'll make use of the IDE auto completion feature. Say hello world, we are learning Java, some text message, right? So basically what does this syntax do? System.out.println is nothing but it will try to print the whatever message we wrote here into the console here. Console in this is the screen, the standard output, the screen of our machine, right? Which is basically this console. So it will just try to print that message in the console. Okay. So now if I try to start compiling this will compile that. Just hold on for a second. Yeah. Okay. Now you can see you have src file, right? In src you would find the hello file. Okay. But if you come back to bin here, there is one bin folder also. You would see hello.class file generated automatically. This is the bytecode of our Java program, whatever we wrote here. Okay, for this program, the bytecode is this hello.class file. So in any Java project, you will have source folder and bin folder will contain this bytecode file of your program. If you remember yesterday, to generate a bytecode from our hello program, we executed the one command, right? Did you guys remember it? Anyone?
It was Java C.
Java C, right? Exactly. So we executed Java C command and then we gave hello. That kind of gave us this particular file, right? Hello.class file. But here your ID is in the background. It is taking care of that. It is in the background as you type program. In the backend, it is executing Java C command. It is generating the class file for you. Okay. So you no need to do that compilation step. Okay, you can just run the Java program. I'm just running the Java program. I'll come here and I'll click on this button here, right? Run. The moment I do that, it will automatically execute the program and see this is the output of this particular code, right? We are learning Java. Because we are just trying to print some message to our console, and that's what it did. That's what it's supposed to did, right? And if you see, this is where my Java installation was there in C program files path Java 11 bin. It is using this java w.exe file to execute my program, right? And it just gave me the runtime, how much time it took also, right? So when I click on this run, it is basically executing the Java command, like what we did yesterday, to get the output of our Java program. Okay, so this is a simple Java program, right? So now coming back to our object-oriented concepts, right? So first of all, let's talk about object. Okay, so basically, what is an object? In general, object can be any real world entity, right? In this example, if you're seeing dog is an object, right? A human is an object. And you can talk about computer is an object, a book is an object, a water bottle is an object, right? Phone is an object. So everything in the real world, any real world entity is in object oriented programming, it's called as an object, right? So that's how we try to model a real world scenario into a computer programming object oriented programming concepts. So we pick one real world entity. Like for example, if you are seeing in the slide, I have a one real world entity called dog, right? Animal can also be a real world entity, right? But I chose a bit more specific, like dog, right? Dog is an animal and dog can be a real world object, right? So first of all, object oriented programming talks about mapping all the real world entities into an object, right? And once we have identified our objects in our programming, then we should come up with two things: state and behavior. So every object that we create in Java will have a state and a behavior. Okay, so basically, what is a state? State is nothing but the attributes, properties of that particular object. For example, if you look at the same example there, right? Our object Java dog has a states like name of the dog, color of the dog, breed of the dog, if it is hungry, right? Yes or no types, right? Statements. So there are different things here, right? And similarly, if you come to behavior, it is basically talks about what does it normally do, what is the behavior of that particular object, right? And here we have dog basically barks, right? Barking is one of its behavior. And fetching, if you throw a bone and it will go and fetch that back for you, right? A ball or something. So fetching is one of its behavior, right? And it constantly keeps its tail wagging, right? So that is also one of its behavior. These are few behaviors. So any real world entity you took, you map it as an object and you try to identify state and behavior of that particular object. Okay, so understood, right? So let's take one example. Let's take car. Okay, so what do you think is the state of the car and what do you think is the behavior of that particular car? Can someone try to draw a similar analogy and come up with something? I gave you a real world entity, another entity called car. So now tell me what can be the state and behavior of it.
So behavior would be driving, brakes,
Right.
and state would be make and model.
Make and model, right? Exactly, right? Thanks for that. Who's that? Okay. Who gave me the answer? Yeah,
Varsha.
Vasha, yeah, that's right, Vasha. Thanks for that, right? So for your car, state can be make of that car, right? And if it is a Ford make or a Toyota make, right? And model can be that respective model within that, and and behavior can be like applying brakes, driving, accelerating. This is the sum of the behavior, right? What else more attributes can we add to state? Can someone give me few more attributes of state for that particular object car, apart from make and model?
Lights.
Okay. Yes, lights can be.
The
Yeah.
year of the car.
Year, right? Manufacturing year, right? Exactly. What else? Cost of the car, right? All these comes to state, right? And behavior, like we discussed, right? Driving, applying brakes, accelerating are some of the behaviors, right? So now let's try to like that, right? Every real world entity you consider, you can actually map it to you can try to segregate the state and behavior of that particular real world entity. Okay, and let's try to map this dog object and its state and behavior into a Java class, right? So now that you identified one real world entity object like dog, and you identified its state and behavior, so let's try to model a Java class. Okay, how can we actually map this to an actual computer program? We'll try to understand. Okay, so we'll have something called we'll create a class. We will say it is a dog, right? So now first thing I need to define is the state of my object dog, right? So I'll come here. I need to define the state. We saw the states are name, breed. Okay. I have issue with respect to keyboard. Let's just name, breed. Okay, and yeah, we'll take only 2 names, and it is also hungry, right? That is also one of the attribute state which we identified, right? Let's just go back to the slide. Okay, name, breed, hungry, and we also have another attribute, color. So color, okay. And coming to the behavior of that particular object, right? You have barking, fetching, right? Wagging tail. So what we can do here is we can say barking, fetching, wagging tail. We can create some method like this, right? Okay, wagging. Right? These are the state attributes, and this is the behavior of that particular object, dog, right? So in general, we can say that every object is nothing but a class in Java. Okay, so I mean it's basically called the otherwise, right? Class is like a blueprint of a particular object. Okay, we will just try to understand this after a little while, right? And when we are talking about the attributes like this, right, and the behavior like this in Java, these attributes are called as so the entire object is modeled into something called class like this. Okay, dog class, dog class. Okay, and within that, all the state attributes, we call them as data members or instance variables or member variables. Okay, so this state has a new name. Okay, one is data members instance variables or member tables. Okay, and the behavior is called as nothing but methods. Okay, so this is a technical term when it comes to Java programming language. Okay, and whenever we see, whenever it be classified like this, right, we need to everything that we write in Java, right, it ends with this semicolon. You need to, okay, and when this is basically, we will just first try to declare the attributes, the state of that particular object here. Okay, so how we actually declare it is, we give it some name and we put the type of data it can be. We need to tell the program, right? If it is a name, what is the name basically? How do you think name will be? What exactly a name is? What type
String.
of data it can be? Right? Yeah, go on. Someone said something.
A string.
String, right? Okay, string. I think you directly gave me the answer, but for the folks who doesn't know it, right? So your name is nothing but it's a combination of an alphabets, right? English alphabets, right? It's basically a text, right? And in Java, we try to map such text-based mix of alphabets things with something called string. Okay, basically our name here is a string data type. Okay, so I need to define a data type like this, string, string name. Okay, the moment I type string name, if you observe, there was some red color mark coming earlier. Okay, the moment I add that data type, it's gone. If I remove this, you will see that error here also. Okay, so this is the another advantage of working in IDE, right? Whenever your class is in red or some of the lines are red, that means there is some problem. It's not completed properly, is what it basically says when you write in IDE, right? So similarly, for every other state, right, we need to identify some data attribute. Okay, and breed is also a string, right? Breed, what are the possible values of breed? It is again a name, right? The breeds can be something like golden retriever or Yorkshire terrier or Shih Tzu, or many breeds, right? In dogs we have. So so it is also a combination of text values, right? Alphabets. So a text value. So it is also a string. And color. Color can be, again, it can be golden color, white color, black color, anything, right? So that is also a string again. So I'll put string here as well. Okay. Now coming to hungry. When we say a dog is hungry, we will have only two answers. Yes, it is hungry, or no, it is not hungry. Yes or no, right? So in Java, we try to represent, so hungry can possibly have two values, yes or no, though they are string, but we always know it won't have another value, another answer when we say if dog is hungry or not. It won't have any other answer other than yes or no, right? And in Java, you have something called Boolean to map this. Okay, Boolean is nothing but it will accept two values, either yes or no. Okay, so Boolean. Let me just. Boolean is one data type. Okay, that's it. Now, if you see, the errors here are gone. Okay, so these are just simply the state of that particular object. When it comes to programming, we need to identify the type of that state, type of the data for your underlying machine to understand that. Okay. Now coming to methods. Method is when we try to define a method, we understand the syntax case. We use this braces like this. Okay. And then in method, we can write a block of statements. So we will put like this. Okay. Understood, right? Like here we will write set of codes, here we will define its behavior, how the dog should bark and all. We will try to define some behavior here. Okay. So your method will contain a braces which will a small regular brackets, round brackets, where we will try to pass the input to this particular method, and it opens, it contains a block like this with a curly braces under inside which we will define some behavior, right? Once I write also, still it is saying it is highlighted in red. If you go here, it says a return type is missing. So I said, right, a method is nothing but it can be function. So when we talk about functions, it is supposed to, when you function is like you gave some input, a function will have a set of statements. It will take that input and the set of statements will execute, and in the end it would return you some result, right? If barking is giving us some result, we need to put the what type of result it is returning. Okay, if it is not returning any result, I'll just simply say void. In Java, to indicate that that particular method is not returning anything, I'll use this keyword void. Okay, when I put void, it's gone. So similarly, let me just try to add to these methods also, right? Just a second. Yeah. So fetching, I'll say probably this is returning some string, assume, right? It's not returning void. This will return some text value, this particular method. So I'll put it as string, and similarly wagging tail. Okay. So this is not returning anything. So this is also returning some object, right? So let's try to put it as string. Okay. So yeah, and I think that's it. Our errors are gone, I think. Okay, but still there is some error. Okay, so basically I'm returning string, right? I need to put some statement like this. Return. If I put this, I think the syntax are just gone. I need to return some string like this. Here I am returning empty string just for the sake forward to avoid that compilation errors. Okay. Now, if you see, right, the compilation errors are gone. Now our Java class is clean. There are no errors. It's compiled successfully, right? So this is how we can map a real world entity like an object like dog with its state and behavior into a computer program like this, right? And if you see, this is not an object. This is like a blueprint, right? And your object is, whenever we talk, class is like a blueprint of your object. So what is blueprint means? What exactly the real-time state and behavior of that particular dog is called as object, and in general what every dog should contain is something like is called as class. So class is like a blueprint, and from class you can create multiple objects, right? For example, for your dog class, one object will contain name as your own pet name, whatever you can name it anything, probably Rocky, and its breed is probably a golden retriever, right? And another object of dog can have a name as probably something like Stalin, and then a breed can be a Shih Tzu, right? Something like that. So every object will contain some actual attributes of that particular class. Your class is like blueprint. It basically tells you how an object should be created, right? So you can think a class as a blueprint for your object, and using class you can create multiple objects. So this way we will pass one statement like this: an object is an instance of a class. Understood, right? From this we can say that an object is nothing but an instance of a class. So that means from a single class we can create any number of objects we want. Okay. Dog is very generic term, right? And object is like more specific. For example, a dog will have some breed and color. An object is nothing but Shih Tzu, white color, golden retriever, gold color, Siberian husky, black and white color, something like this. These are the objects of that dog class. I hope you understood this concept, right? So this is what class and object are about in object-oriented programming. Now let's talk about other concepts. So far, is it clear, or any questions here, guys? I understand there might be a lot of
Is good.
technical terms we are using, but yeah, initially there will be a lot of jargon. I know it might be going with the too much theory also, but it's really important. This play a key role in getting you into Java programming, right? So I hope the whatever discussion we are having with respect to class and object is fine, right? So in general, object oriented basically talks about any real world entity that you see, try to map it into a class and object is what object oriented programming talks about. So it basically works on objects, right? Object oriented programming, as the name itself says, it is oriented towards objects, right? The programming model. Now coming to the first key principles of OOP, right? Encapsulation. Okay, what is encapsulation, right? Encapsulation is basically, it is a mechanism, okay, a mechanism to bind our code and data together. Okay, so how Java basically achieves encapsulation, right? It is nothing but using the class. Here our data and the code, like methods, behavior, everything is binded together into something called class, right? So encapsulation is nothing but binding your code and data together using class mechanism. So that's what encapsulation is talking about. So indirectly, whenever you create a real world entity and map it to a class like this, defining its own attributes like instance variables or member variables, when you define and corresponding methods, instance methods, when you define it, that is nothing but encapsulation. So you are basically binding the data and the behavior together into a class, right? This is called as encapsulation, right? And it is not just that, okay? It also talks about how this particular data and these methods can be accessed, okay? So that's where Java introduces some keywords called access specifiers, okay? And we have 4 such access specifiers, okay? So they are yeah, they are I'll just type here, okay? So they are public, private, protected, and default. Okay, look at these keywords. Okay, here if you see this program, how many keywords we came across, right? We came across so many keywords. Public one keyword, class one keyword, string is one keyword, void is one keyword, return is one keyword, right? And now you have now I'm talking about a new set of keywords: private, protected, default, and we have another keyword, right? Public. So let me just copy that and put it here. So basically these are called access specifiers, right? So basically when I try to take this public and put it here on in front of class, I can just remove this public also. Okay. This is also fine. But when I'm putting some access specifier like public in front of it, that basically means that to what extent the outside Java classes or outside entities or outside objects can access this class. When I say public, this doc is public to everyone. Any real world entity can come and access my doc class, right? But when I make it as a private, when I make this as a private, then my outside entities cannot be called, cannot be access my doc class. Okay, so in Java there is no such as private class. Okay, if you see the moment I put private, it throws a syntax error, right? So in Java all classes are default and public by default. Okay, so I can't create a private class in Java, remember that. Okay, so now having said that, you have you define certain access we also call this as access modifiers. Okay, when you put public, that means you are saying my outside entities can actually access my doc class, right? So that means this is hello, this is another Java program, right? Here I can actually access dog, let's say dog h. Okay, did it give any error? No, right? So I can actually make use of this dog object. Okay, in my hello programming, a different Java class, I can make use of dog object or dog class there. So that's why that's what public does. If you remove public and make it something, I told you private is not there. But if at all, if you have private something of that sort, right, you would definitely can't access it here. Okay, that's one key difference. And let's just try to understand this bit more by putting these things, by adding some access specifiers, just not the class, right? The state and behavior, the attributes, the instance variables and methods will also contain some access modifier. So basically, if you look at here, I haven't mentioned any access specifier with keywords public, private, or protected, or default, right? So when I don't specify, by default, they all contain the default access specifier. Okay, so I can override it by saying public. Okay, so I'll say public, I'll say public, I'll say public, public. Just put that keyword in front of everything. Okay, so public, public void barking, public string, okay, keyword. So that means now I can actually access in my hello program these variables I can access. Okay, I'll say h dot, if you see I can access this breed, color, hungry, barking, fetching, right, wagging tail. I can access these things here, wagging tail, right? Or I can access h dot breed. I'll say it as I can assign it some value like golden retriever, right? Or Shih Tzu, something like this, right? I can assign it some name. Okay, like this. It gives an error because we haven't initialized that object. So probably let me just put it like some null. So it will go off. Null. New LL. Null. Okay. So the compilation errors are gone, right? So using this dot operator, right? H dot, I can access, h is nothing but it's of type dog, right? So I can access all these variables that I have declared here, right? So the moment, let's assume I was accessing here what? I was accessing breed, right? So since it's a public, I can access it here, but let me just try to change it to private. Okay, now come here, see if it gave an error. It is because, like let's see the error first. Dog.breed is not visible because when you make it as a private, that means even though dog class is accessible outside, inside dog class, breed cannot be accessed by other Java classes or other objects, right? So private makes it more protected. Okay, it basically restricts access to that particular data for the data of dog class, which is breed attribute to the outside classes, right? So we are making it more secure, right? So that's what private does us here. So when I put private, it gives error. I actually can't use like this. Okay, but still I can use others like h dot wagging tail. I can call this method and it will perform some functionality. I can call this name, color, because rest all are in public scope, right? So always the best practice in Java is to always put all your state variables in a private. Okay, and you should make your methods public, right? So whatever values you want us and manipulation you want to do with respect to state, you do inside a method, and from outside world you just access the methods only. This is the best practice in Java. Okay, always create your variables as private and your methods as public, so that your outside worlds only can modify the behavior, not the state of dog. Okay, understood, right? So they can't, if they start outside objects, if they start modifying data, then eventually your programming will become complex, and it will the data may also contain wrong data, right? Someone from outside, they will come and they will assign a color like golden retriever. Golden retriever, it's not a color value, right? Golden retriever is a breed attribute, so they can make the data inconsistent. So it's always good approach to put, but it's always suggested and preferable to put all your variables in a private scope. Okay, so protected and default, how does it do is, it has its own, like here you have which package this doc class belongs, java.training, right? Now I can have one more package like this. Okay, training one, a different folder. So here also, let's assume I have a Java class. Okay, hello.java. If you see here, there is an error. What is that error? Dog. Okay, see, I need to import this dog. Okay, it's done. Now I can access wagging tail here, right? I can, because since dog is public, I can access wagging tail across any packages, right? This is another folder altogether. Suppose if I come to dog here and I make it protected, the wagging tail function, let's just see what will happen. Okay. So if you see here in this hello, there is no error because this hello and dog, they belongs to the same package, that is same folder structure, java.com.training. But if you see here it is giving an error. Though all this belongs to same project, the hello.java here is belonging to a different package name altogether, training one. Okay, it is not part of the training folder, right? If you see here, let me just open the System Explorer again. Show in System Explorer, Java course one, src, com, Java. If you see, you have two folders, training folder and a training one folder, right? Your training one folder classes cannot access wagging tail because in dog it is protected state, but it can access barking and fetching. Okay, let's just see that. So when I type h dot, it will give you barking and fetching because they are public in nature, right? Go here, they are public. Okay, so this is what encapsulation as a principle talks about. Okay, so to control, this is how using access specifiers. So encapsulation is nothing but, it encapsulates nothing like, think of a capsule, right? Inside a capsule, it contains some data, right? So similarly here, our capsule is a class, and inside that capsule we have our data and the behavior of that particular object. So in Java we achieve encapsulation using class, as simple as that, because a class binds the data and its variables together, right? And in addition to that, we also need to control the access to that particular data and the behavior, right? For that, in Java, we make use of these access specifiers, access modifiers, using keywords public, private, protected, and default. And we took a couple of examples on how it actually works when we gave it, right? How that mechanism basically works. Basically, it restricts the outside entities or outside objects to control the access to our particular data, right? So this is how Java achieves encapsulation in encapsulation in I mean, this is how Java basically implements the object-oriented encapsulation concept. Okay, I'll stop it here, guys. Any questions? Any questions, guys?
No questions.